In part 2 of rational expressions, we're going to talk about compound fractions. You ran across this in Algebra 2 Honors, and you probably did something similar to the example I'm about to do, but we're going to talk about some even more complex compound fractions, or you may have called them complex fractions. A compound fraction is a fraction in which the numerator, the denominator, or both are themselves fractional expressions. So here's an example of a compound fraction, x over y plus 1 all over 1 minus y over x. In order to simplify this, we're going to start by making both the numerator and the denominator a single fraction. Right now, the numerator is not a single fraction. It's a fraction plus a second fraction. Remember, 1 is the same as 1 over 1. The common denominator for the numerator is going to be y, because one denominator is y and the other one's 1. So the first fraction I don't need to do anything to, but the second fraction I need to multiply by y over y. In the denominator, the least common denominator of those two fractions is going to be x. So the first fraction needs to be multiplied by x over x, and the second fraction needs to be multiplied by nothing. So now the numerator becomes x plus y over y. The denominator becomes x minus y over x. This fraction bar is a division symbol. So if you're dividing two fractions, that's the same as multiplying the fraction in the numerator times the reciprocal of the one in the denominator. So now this becomes x plus y, all over y, x minus y. And nothing here can be canceled, so this is the final answer. Here's an even more complex compound fraction. Remember, when you look at these problems and you start to ask yourself, when will I ever use this? The actual answer is, you probably won't ever do this again. However, it's the process of problem solving and trying to manipulate mathematical expressions for what you need to use that becomes very important in the future. So remember not to say to yourself, I'll never use this again, and instead say to yourself, how do I problem solve something that I'm not sure how to do? Because that's the important lesson coming out of this. So in this problem, when we go and simplify compound fractions, anytime we have multiple fractions being added or subtracted, we want to first combine them into a single fraction. The least common denominator is going to be a plus h. Like I said earlier, probably in the last video, a lot of times the least common denominator is just the product of the denominators. So the first fraction needs an a. The second fraction needs an a plus h. I even think I said to do this, just to make it a little bit nicer. Instead of it being a subtraction problem, make it an addition by a negative. Now I'm going to multiply the numerators out. So I'm going to get a minus h all over a plus h. That's the fraction in the numerator. Don't forget the denominator has an over h. We're still simplifying the numerator here. The a minus a, they cancel, and you're left with negative h over a plus h, all over h. Because a fraction bar is a division problem, what we're actually going to do is we're going to take the fraction in the numerator and we're going to multiply it by the reciprocal of the denominator. And you may notice that those are common factors. So you actually get left with negative 1 over a plus h as the simplified fraction. We've we've run across a problem similar to this one before, where we had expressions with rational exponents. When we have a problem like this, we want to factor out the factor with the smallest exponent. Well, the factor with the smallest exponent is this. So in just the numerator of the fraction, we're going to divide both terms, and there are only two terms, by 1 plus x squared raised to the negative 1/2. Remember that factor means divide. So what happens when you divide this part by 1 plus x squared raised to the negative 1/2? That's the case where you subtract the exponents, but 1/2 minus negative 1/2 is really 1/2 plus 1/2, which is 2/2, which is 1. And then over here, you have your minus x squared, and then 1 plus x squared to the negative 1/2. Well, when you divide those, they cancel, they become 1. So this is what you're left with in the numerator. Don't forget, we factored out a 1 plus x squared to the negative 1/2. And when you factor it, it just gets written in front. Now, I'm going to keep simplifying. 1 plus x squared minus x squared, well, that's just 1 plus 0, which is 1. And then 1 plus x squared to the negative 1/2 times 1 is just 1 plus x squared to the negative 1/2. All right. Remember that this is to the first power. So I have a common base, and I'm going to simplify this by subtracting the exponents. So negative 1/2 minus 1, which is negative 1/2 minus 2/2, is negative 3/2. So this really becomes 1 plus x squared to the negative 3/2, which is the same as 1 over 1 plus x squared to the 3/2, because negative exponents, we move it. So if a negative exponent's in the numerator, it just gets bumped to the denominator. If it's in the denominator, it gets bumped to the numerator. And now we have a little bit nicer, cleaner looking problem. In calculus, we often need to simplify algebraic expressions in order to do things called derivatives and integrals. We'll see those a little bit later in the school year. Well, in order to rationalize a numerator, you've already rationalized a denominator, so we'll review that in a minute. We use something called a conjugate. We've run across conjugates a couple of times. We talked about them when we talked about complex numbers. A complex number is a number in the form a plus bi. The conjugate of a plus bi is a minus bi. The purpose of a conjugate is that when you multiply those together, they're in the form a plus b times a minus b, which means you're going to get a squared minus b squared. The problems that we're going to run across, or that are going to affect us for calculus, are conjugates with a radical. So the conjugate of a plus the square root of b is a minus the square root of b. And the same thing's going to happen. What's basically going to happen is when I multiply this out, the radical is going to go away. That's what rationalizing means. It means get rid of the radical. Now, so let's start with a review of rationalizing a denominator. This is something we've already done. To get rid of the radical 1 plus the square root of 2, we're going to multiply this fraction by 1 minus the square root of 2. But really what I'm doing is I'm multiplying the fraction by 1. Because if you multiply the fraction by 1, you're not really changing it. You may change the way it looks, but its numerical value is still the same. So, when I multiply the numerators, I'm going to get 1 minus the square root of 2. When I multiply the denominators together, I'm going to get a squared, which is 1 times 1, minus b squared. Well, the square root of 2 times the square root of 2 is the square root of 4, which is 2. So I get 1 minus the square root of 2 all over negative 1, and that simplifies into square root of 2 minus 1. If you're wondering how I figured that out, literally what I did was I divided both of these by -1, and I got -1 plus the square root of 2, which is the same thing as the square root of 2 minus 1. However, it is rationalizing the numerator that we're going to do again as we move into our study of calculus. So, to get rid of the radical in the numerator, we're going to multiply by the conjugate of the numerator, which is the square root of 4 plus h plus 2. The reason we do that is because when we multiply the numerators together, they are in the form a minus ba plus b. So we're going to get a squared minus b squared. Well, the square root of 4 plus h times the square root of 4 plus h is 4 plus h, minus 2 times 2 is 4. And I'm going to leave the denominator like this. I'm not going to distribute it out, or at least I'm not going to distribute it out at this time. So now, the numerator has a 4 minus 4, which is 0, so you're left with h over h, the square root of 4 plus h, plus 2. Wait, those h's are common factors, and they cancel. Now, when they cancel, you're not left with 0 in the numerator. You're left with 1, because 1 is the coefficient in front of h, even though we don't write it. So this is the answer you get when you rationalize the numerator. And I'm putting a big star here because this we're going to do several times during the course of this school year. A lot of these properties that we've talked about lead to some very common errors that students make. I want you to look at these properties. These are not errors. These are all true properties that we've run across in our lectures. Like a times b squared is the same as a squared b squared. The square root of a times b is the square root of a times the square root of b. The square root of a squared times b squared would be the square root of a squared times the square root of b squared, which is a times b. 1 over a times 1 over b is 1 over a times b. A times b over a, the a's cancel and you're left with b. A to the negative first times b to the negative first is the same thing as ab to the negative first. All of these properties were either multiplication or division. Not a single one of them had to do with addition or subtraction. That's where our common mathematical errors pop up. A lot of people love to believe that a plus b squared is also a squared plus b squared, but it's not, because this property does not hold true for addition or subtraction. The square root of a plus b is not equal to the square root of a plus the square root of b. 1 over a, let me see, I'm skipping one here. The square root of a squared plus b squared is not equal to a plus b. 1 over a plus 1 over b is not equal to 1 over a plus b, or 2 over a plus b as the case may be. A plus b over a is not equal to b, and a to the negative first plus b to the negative first is not equal to a plus b to the negative first. All these properties only hold true for addition or for multiplication and division. None of them hold true for addition or subtraction.